Hey, good morning, everybody. So today's a little day two of the review for the most part. So we're going to get through the graphing stuff today for the most part. And then tomorrow it'll be entirely yours, asking last minute questions and work on the review assignment, things like that. So you know the drill. It's the same thing as it is for tests. Then, of course, don't forget that you have to finish your notebook checks. I'll be still continuing to work on that today and tomorrow. So I'll get those taken care of. You're welcome to come in during seminar too and get those checked off in your own free time if you like, but I'll get it done in class time. You don't need to worry about that if you don't want to. And extra credit is going to be due by the time you take your final, as is your review assignment. So again, remember, everything needs to be pretty much ready to go and turned in for the semester when you show up to take your final. Extra credits turned in, review assignments turned in, then everything, and then you take your final and you are done. So that is all. Let's continue to review today. So warm up today, just going over some of the things from yesterday and going into some of the things from today. Number one, what are the definitions of all six trig functions in terms of x's, y's, and r's? Well, again, when the test comes, I'm just going to give you this picture right here, and I expect you to know how to break this down and put it in terms of y's, x's, and r's. So one more time, just like yesterday, SOHCAHTOA is all you need. This acronym and this picture tells you everything you kind of need for the unit, except for like pi equals 180 and things like that, periods. But so sine's opposite over hypotenuse, and this picture, that'd be y over r, correct? Similarly, if you did cosine, that's adjacent over hypotenuse, that would be x over r on the picture. If you did tan, then that'd be opposite over adjacent on the picture, that would be y over x. And then, of course, you should know that the 3 ones flipped, sine flipped is cosecant, so cosecant would be r over y. Cosine flipped would be secant, so that'd be r over x. And cotan flipped is tan flipped, and they're the same thing, so x over y for the cotan. And that's it. Any questions over how to figure those out based on the picture? I don't think so. It makes perfect sense, doesn't it? So we're good on that. And when the test comes, you might want to take just half a second, look at the picture, write down these 6 equations, and then you can just use them without even going back to the picture ever again, things like that. Good stuff. So we got everything we might need for that right there. Going on to number 2, how do you convert from degrees and radians to degrees? How many radians are halfway around a circle? How many radians are all the way around a circle? Well, that's not something that we haven't done before. How do you convert? Let's say you had degrees. You had something degrees. How would you convert that? What's the conversion? Yeah. Pi is 180. I like what we're saying. So yes, the degrees will go on the bottom in this case, correct? Because you want the degrees to cancel out. Conversely, if you had some number of radians, so pi stuff in them or something like that. So let's say you had, I don't know, I'll put like pi over something or some number pi, something with pi's in its radians. Then, of course, you would multiply by the 180 over pi because you want the pi's to cancel out. So don't forget that. That's pretty straightforward, how to convert back and forth between the two. Also, things you should know is what is halfway around a circle in radians? Well, you just use the conversion. Pi, yeah, 180 is halfway around in degrees, right? So halfway around in radians is pi. So halfway around is pi. And if halfway around is pi, then all the way around would be 2 pi. Yep. So that's kind of the basics you should know about these things. And by default, sine and cosines graphs will repeat every 2 pi because that goes all the way around. Anything based on sine and cosine, which one's flipped? Are cosecant is sine flipped, right? Secant is cosine flipped. These guys' periods would also be 2 pi because they're based on this jerk. The only one who doesn't have a period of 2 pi by default is tan. Tan's period is normally 180, which is just pi, right? So this one's period is pi, which means its flipped version is also pi. So that's the basics about the periods of those things. And speaking of, number 3 is asking us, what do the graphs of sine and cosine and tangent and all those kind of things look like? Well, you should know for sine, it should be pretty much in your mind right now what sine looks like. It starts where? 0, yep, starts at 0, goes all the way up and down. How high up and down does it go? These sines and cosines do have amplitudes associated with them. Definitely have some amplitudes. They're the only 2 that have amplitudes, because what do all the other 3 ones do? Tan blows up, doesn't it? It goes all the way up and down. They have no amplitudes. And if you flip all these things, they go up and down forever, right? So they don't have amplitudes either. So just sine and cosine, you have to worry about amplitudes for. But yes, again, it repeats every 2 pi. Good to know that that's the period of that thing. Or if you want to work in degrees, which is what your test is pretty much in, then that'd be 360, right? And then don't forget, for these, especially with sine and cosine, every fourth is something of interest, right? Peaks or zeros or something like that. A fourth of 2 pi is pi over 2, because if you took 2 pi and divided by 4 and reduced it, you'd have, well, pi over 2. Then the next one, the 0, would be at just pi, and then another one over would be 3 pi's over 2. And those are the highlights of a sine graph right there. You need to know those highlights, especially if you need to flip it to turn into a cosecant graph. Cosine's really no different. The only difference is that cosine starts up at 1, right? Starts up at 1, goes down to -1. It still repeats every 2 pi, and the same things of interest are there. Pi over 2, pi, 3 pi over 2, same exact highlights. Everything is literally the same thing. Cosine is really no different than sine, except you got to remember to start high instead of starting at 0. So you need to know those two. And you also need to know, of course, tangent. And by default, tangent has asymptotes. It does blow up at 2 numbers, plus or minus pi over 2, which is equivalent to 90. So 90 degrees if you want to talk in degree world. And then the normal tan thing, it starts, hugs this one, goes up right through the origin, and shoots up right there. That origin's a key point you could use to do any shifts or anything like that, but I'm not going to try to stress you out with too many shifts and all that. Questions over the sine or the cosine or the tangent graph? And then for any of these, if you need to get their sister functions, their reflected functions, it's the same process. In fact, it works for any function. It doesn't not just trig things. If I ever ask you, what's the graph of 1 over something? Well, what you do is you look at the something, and all zeros become asymptotes, right? So if I was graphing cosecant, these would have these asymptotes. If I was graphing secant, then these zeros would be asymptotes. And if I was graphing cotan, then this 0 would be a new asymptote. But if zeros become asymptotes, then asymptotes become zeros. So on your tan graph, these old asymptotes would actually be zeros for the new thing right there. And then if you want to draw the rest, just remember increasing and decreasing kind of switch roles, but the signs stay the same. So this one was positive. It was going up and down, so it goes down and up. And then this one was going down and up, so it goes up and down. Same thing for the cosine one. This one was going down, so this one would be going up. This one was going down and then up, so up and down. And then this one was going up, so the flipped one would be going down. And for cotan, following it very carefully, there's a 0 here. This negative, so it'd still be negative. It was going up, so this would be going down. And the flipped version was positive and going up, so the flipped version would be positive and going down. So those blue ones are kind of their reciprocal functions that go along with them, and you got all the things you could possibly ever want for that. Questions over anything about the basics, guys? All right, well, today we're going to practice graphing sine, cosine, and tangent, talking about all their key features. And then we're also going to go ahead and, of course, do some problems from the review assignment, all that jazz. After we're done with all that, we will get to work on checking off warm-ups and learning goals still. Definitely I'll get those done by tomorrow, because tomorrow is pretty much a work day, so I'll have lots of time to check things off. But continuing to review, that's our main junk. Graphs. When the test does come on the board, I will have all the equations that you need to make the graphs of things. The main thing you need to worry about is things periods. You need to know what the period for sine is and the period for cosine. And if I put a b in there, like cosine of 4x or sine of 2x or something like that, you need to know how that stretches the period by the equation. You need to identify asymptotes, midlines. If I ask you for frequency, there's an equation on the board. You just do 1 over your period. It's not that bad. But really don't put this stuff on too much of a pedestal. If you know what sine, cosine, tangent look like, and you have a graph of sine, cosine, tangent in front of you, don't you? I gave you a handout of that, so you have a graph of what sine and cosine tangent looks like by default. And hopefully we can stretch it and shift it and all that nonsense. Okay, continuing today. Let's see what we got. 11.7, the reveal stuff over inverses is due today, so make sure that's turned in. And then, of course, that's it. You just got your review assignment to worry about. Any extra credit, all that stuff, again, like I mentioned, due when you take the final. So let's continue our review. We are doing sections 11.4 on today, graphs of sine and cosine and tangent. Really quickly, here's your highlights. You know what all these terms mean? Midline, it's the line through the middle, right? Makes perfect sense. It's a horizontal line. Amplitude is how high it goes, but just measure from the halfway point up, right? The height from the midline to the top or the midline to the bottom. It's not the total height from top to bottom. No, no, no. It's just halfway up to the top. Period, how often it actually repeats, and frequency is how many cycles occur per unit time. Not that you need to know that, you just need to know how to flip it. And here's the shapes. We've gone over it already. Sine starts at 0, correct, goes all the way up, comes back down, repeats every 360. Fair enough? And what's cosine do? Starts at 1, goes all the way down, comes back up, and repeats after 360. In general, these are called sinusoids. And here's what I'll have on the board for you about sine and cosine right here. You know what to do with all these equations right here? Remember, the amplitude is always the number in front of these trig things, but make sure it's positive. So I updated my slides. It's actually like an absolute value, because if there's a negative or something like that, you know what to do with the negative. That just flips it, right? Vertical reflection kind of things. Period. As we've stated, by default, it's 360 or 2 pi if you're in radians. But if there's a stretch, a horizontal stretch by b inside of here, you need to divide by the b to get the new period. Midline is normally 0, but of course, if you put plus something on the end, it shifts it up and down. So the midline would move up and down by whatever you add on the end, d. And if I ask you if I find the frequency, all you got to do is just write 1 over whatever the heck the period happened to be. Not that bad at all. Don't forget that everything interesting on sine and cosine happens fourth of the way through the cycle. So the first fourth of the way, there's a peak. Next fourth of the way, there's a 0. Next fourth is a minimum. And then the next fourth starts all over again at another 0. And same kind of thing with cosine. Questions over the basics, anybody? All right. So there's sine or cosine, either one, same kind of thing. We'll just go on to the other ones. Tangent, by default, there are 2 asymptotes at negative pi over 2 and pi over 2, but they do repeat every, what's the period for tan? It's 180, isn't it? So you can expect that if there's one at 90, there'll be another one at 180 over, another 180 over, there'll be another asymptote, and another 180 over, another asymptote, another asymptote, another asymptote. Tans start low, go through the origin, and go on up. And then that pattern just keeps going over and over and over again. So key things are zeros are at 0, and asymptotes are at negative pi over 2 and pi over 2, i.e. negative 90 and 90. And here's your stuff for tangent. These look familiar? Yep, pretty much exact same kind of things. It has no amplitude. You've got a similar equation for the period, just like sine and cosine. The only difference is that since tan repeats every 180 or every pi, by default, it's 180 over b, and if you stretch it, things like that. Here's an equation for where the vertical asymptotes are, but don't forget that they keep repeating, okay? Every period, you can move over and draw another asymptote and draw another asymptote and draw another asymptote. That's what a period is. And then you got your frequency right there. Then you got your 3 freak ones. And as we just discussed, how do you graph cosecant? Well, first off, you got to know cosecant is sine flipped, right? So you kind of draw your outline of sine. And what do you do? How do you flip things? Well, here's your kind of master thing. Zeros become vertical asymptotes, and vertical asymptotes become zeros. If there's any max, it'll turn to a min. If there's any min, it'll turn to a max. Main thing is increasing and decreasing switch roles, but the signs stay the same. So notice that this orange one is above the axis. It's positive, correct? The flipped one is also above the axis and positive. This orange part's negative. So the flipped version is also negative down here. And then increasing, decreasing changes roles. Here was a 0, so the flipped version will be an asymptote. It'll hug it right there. It was going up, so the flipped version will go down. The original thing was going down, so the flipped version will go up, and so on and so forth. This one down here, here's some asymptotes, so it has to hug that. It was going down and then up, so this one will go up and down. And the exact same pattern goes with all the other 2. Secant, if you flip it, increasing and decreasing change roles. Cotan, if you flip tan, be careful when you're flipping tan. Infinities become zeros and zeros become infinities, but it looks something like this blue one right here. And that's pretty much all there is to it. Last couple, well, let's take a break. Let's do some problems about graphing these things. Let's look at our review assignment and do some graphing stuff. I think it's probably fair that I'll give you one of the basic ones, sine, cosine, or tangent. I'll give you one of those. And then I'll also give you one where it's one of the three freak ones where you got to flip it. So let's pick out one first that's just a sine, a cosine, or a tangent. Anybody want to do a sine, a cosine, or a tangent? 24. Here we go. Let's write her down. Number 24 has the equation that y is -2 sine of 4x. So what do you do first? Well, kind of for any of these trig functions, I wouldn't even worry about the numbers in front. I wouldn't worry about any pluses on the end. I would just worry about what sine of 4x looks like. If you can figure out what that is, well, shoot, we can make it 2 times bigger, can't we? And then we can flip it too, right? So let's start there. What's a graph of sine of 4x look like? And on scratch paper, you might want to go off to the side and just figure that out real quick. I wouldn't do all my work on the graph that's being turned in. That's just me. Well, if you get out your equations for sine, the first thing it says is that your period is 360 over b or 2 pi over b. Now, if you look at your axes, you're welcome. What are these all measured in? Degrees. So you don't have to do any weird radian stuff. It wouldn't be any worse if you had to. So we'll use this version, the 360 over b. And b is clearly 4, right? So it's going to be 360 over 4, which is 90. So this is our template so far. This is not the official answer, but it has 3 tick marks until you get to 90, and then the rest is just a bunch of other stuff. I only make sure you draw it so that the whole cycle just repeats every 90. You said the period's 90. Dang it, it better repeat every 90. So just this piece, sine, starts at 0, correct? Goes all the way up to 1 and -1. So it goes all the way up, all the way down. Kind of, whoop, that's not quite enough, is it? Let's make it up here. Goes all the way up, all the way down, and it should come back at 90, right? I'm not going to be too picky on you. If it's a little slanted or something like that, that's okay. What I'm really scanning for is you understand that the period's 90. So dang it, you better have the whole thing repeat after 90. Now that's just sine of 4x. The 2 is the amplitude, correct? The amplitude is 2. In fact, they want us to write all these things down, don't they? So let's just go write them down. They say, what's the amplitude? You say 2. What's the midline? Well, is there going to be, there's nothing on the end to move it up and down, is there? So it's still going to be through, what, 0? So write down y equals 0 for the midline. Where are the zeros at? Oh, boy. Well, let's think about this. Well, I see one at 0, don't you? That's something. Write down 0. There's one at 90. That's something, right? And there looks to be one right halfway in between. It's every fourth, right? The first fourth would be the hump, right? The second fourth or halfway would be right there. What's half of 90? Okay, so how about 0, 45, and 90? That's a good list of zeros. Vertical asymptotes? No. I'm putting that on every single problem because sometimes for tans or cosecants there are some, but it doesn't apply. Yeah.
You just put
NA, yep. Curse me out. Anything besides a number. Don't write a number. Period, we already figured out that. That's 90, correct? And the frequency, well, how do you do frequency? It's just 1 over your period, so write 1 over 90. But we're still not quite done with the graph. This was just sine of 4x, right? We never did the 2, we never did the 1. You said the amplitude was 2, so it shouldn't go up to 1. It should go up to 2 and -2. But also we have a negative, so the whole thing needs to get flipped, correct? So now that I kind of know what the whole thing's going to look like, now let's put it on the actual paper. On the paper, 1, 2, 3, here's our 90. It's going to go not between 1 and 2, or -1 and 1, but -2 and 2, correct? And with the flip, it won't be going up and down, it'll be going down and up. So start down here, go down here, come back up here, and as long as you hit that spot where you started at, after 90, even if it's not perfectly pretty. Mine's not perfectly pretty. It's not symmetric. That top looks a lot smaller than the bottom. It doesn't look perfect. I don't care. Main point is you told me what the period is, and it looks like this. By the way, don't you have a graphing calculator? Can't you go graph these two to double check that you have the right shape? Yes, you can. Make sure you're in degree mode, though, and make sure you have an appropriate window. Normally, your window is what? -10 to 10? That won't cut it if you're going out to 90, right? So you have to go to like your X max and at least make it 90 and make your Y as it lists these. And you should see a graph that kind of looks like this right here. So you can check yourself on that. Any questions about how we broke that down one little stupid thing at a time? Any questions at all about the sine graph? All right, let's just do one more then. Find something on your review assignment that's one of the freak ones where you flip it, either a cosecant, a secant, or a cotan. Any of those. 27 it is. So 27 is y is negative. We'll deal with that at the end, right? So whatever graph we get, we're going to flip it. Secant of 3x. Well, let's just worry about secant of 3x. But I don't know what secant of 3x looks like. But I do know secant is which one flipped? Cosine, yes. So let's just worry about cosine of 3x. If I can worry about cosine of 3x, I'll flip it to get this, and then I'll actually vertically reflect it to get the final answer. So we're really looking at a cosine thing again. Well, let's see here. Period, that's the main thing, period. Again, 360 over b. B is 3 this time, and 360 divided by 3 turns out to be 120. So this thing dang well better repeat every 120 degrees. Now, just again, off to the side, I wouldn't put this on my paper, but you can if you want. Just got a lot of erasing to do. Let's just worry about what this graph looks like. Well, cosine starts high, correct? First off, they got a bunch of tick marks again. If this is 90, what's it going up by? There's 3 tick marks. This must be going up by 30, right? So wouldn't 30 more be 120? Okay, so this is where I'm going to try to get back to. Cosine starts up at 1, goes down to -1, so we're going to go all the way down, all the way back up, and hook right back up where we started after 120. So far, okay? All right, that's roughly what this thing looks like. Since I'm going to flip this thing, it's probably a good idea to figure out where the zeros are and all that kind of junk. So remember, everything interesting happens every what? 1/4 of the way, correct? So get your calculator out and figure out what 1/4 of 90 is. I don't know what that is. I do, but I want you to figure it out. What's 1/4 of 90? All right, so the first interesting thing happens at 22.5. The second interesting thing is bottom. It's going to happen another 22.5, which is, guess what? It's 45 degrees. Then another 22.5 would be 67.5, fair enough. And then another one would be back to that. So that's a pretty good outline of what cosine of 3x looks like. But of course, we're not doing cosine, we're doing secant stuff. So we got to flip the thing now. So let's see what we got. Here's a 0. What happens when you flip a 0? That's right. So right there at 22.5 degrees on the thing I actually care about, this thing's going to blow up. The other 0 is over here at 67.5, so there's another vertical asymptote I'm going to have to play with. There's no infinities to flip. There's nothing else. So the rough outline of secant will be, instead of it going down, it'll go up, right? This version, there's the asymptotes. It's negative, so it's going to have to hug those. It's going to have to come up and go down, right? Complete opposite. This one's a hump going up. This one's a hump going down. So it's opposite humps, right? Opposite humps, basically. And over here, it was going up, so it'll be going down. So this blue one is a rough sketch of what secant of 3x would look like. There's secant of 3x. And then there's one more thing to consider. What are we after? We're not after secant of 3x. Negative. So I'm going to take this picture and literally flip it. So finally, maybe I'm ready to write my final answer on the paper provided. Here we go. What's going to happen on my paper? Well, there's a vertical asymptote at 22.5. Where is 22.5? That's kind of hard to spot, isn't it? Because these go up by 30s, don't they? So a little bit over here. This is kind of why you also want to write down what the vertical asymptote is, because it doesn't always land on a tick mark sometimes. So this time it doesn't. We said there's another vertical asymptote at 67.5. This is 30. This is 40 or 60. No, wait, this is 30, 60. So wait a minute. What am I doing? Let's go up by 30s, right? Yeah. So 30, 60, 67 would be here-ish, something like this. So x equals 67.5 degrees. Good to know. And now to actually draw the picture, the only thing we didn't do with the blue is we didn't flip it, right? So let's flip it. This one was up at 1 going up, so the flipped version would be at -1 going down. So find -1. Start right there as a thing, and then have it go down and hug this asymptote. Then, let's see here. We had the blue one going down here, right? So if I flip it, it'll be a blue one going up from 1. So come here, come down like that. We're cool. And then on the other side, lastly, we had a blue piece that was up here. So if I flip it, it'll be going down. So this piece kind of hugs this thing and goes back up to -1, doesn't it? And dang it, this thing repeats every, what was the period? This one was 120. So this last one better hook up at 120. Could you graph this and check it? Yeah, you could. How do you graph secant? There's no secant button. You do 1 divided by what is flipped to be secant? Cosine. You graph 1 over cosine of 3x and you're done. So wrapping it up, let's see all the things that we didn't fill in. Amplitude, is there an amplitude for things that go up? No, so you put a slash through that. Is there a midline? Yeah, there's a middle, would you agree? So what, still 0, I think, 0, yeah. Are there any zeros? Does this graph cross the x-axis anywhere? No, so put a slash through that one. Are there vertical asymptotes? Oh yeah. 22.5, right? And 67.5. And the period, as we said, was 120. So your frequency, which is always just 1 over your period, would be 1 over 120. And that's all there is to that. On the test, I don't even think I'll probably even put any negatives in front. I'll just make it real simple. You know, that's a lot to do. You got to flip, you got to make the original graph, then you got to, you know, flip the graph, and then you got to vertically reflect it. It's a whole bunch of things. So I'll probably keep it real simple. I'll probably give you like a secant of 2x. Here's a cotan of 4x. I probably won't put any negatives or stretches or shifts or anything to make it, because it's complicated enough. Don't you agree? Okay. Sounds good to that. All right. Any questions over graphing any of the 6 trig functions at all? Anything at all? All right, finishing up then. We did do a couple more sections. 11.6 was about shifting trig functions up and down and left and right. Like I just said, though, I probably won't do that for anything weird. I might do that for like a sine or a cosine, but I might not. I'm definitely not gonna do it for the other freaks. And there was something called a phase shift that represents your horizontal shift. You don't need to worry about that. It's not on your reviews assignment anywhere, is it? Nope, it won't be on your test anywhere either. But just FYI, that's what they call it when we're shifting trig functions back and forth. But we did talk about inverse trig functions. And again, when you're doing inverses, they might call them arc sine for sine inverse. They might call it arc cosine for cosine inverse, or arc tan for tan inverse. But these are the only inverses you need: sine inverse, cosine inverse, and tan inverse. And you got to know where to look on your graphs in order to do these inverses. So on your trig graph for sine, down here I had you highlight the range, correct? Remember that? So if I said go find sine inverse of a half, first off, is it on your y-axis? Does sine equal half somewhere? Yes, it does. Lots of places though, right here, here, here. The one you pick is by where the range is. So for sine, you'd only look between -π/2 and +π/2. And in between those ranges, the only place where it's a half, it would be π/6. So if I said sine inverse of a half, you tell me the answer is π/6. Does that make sense how to do that? Okay. What if it's not on the y-axis? Then you do it with your calculator. You just type it in and crank out a number. And it's no different with any of the other inverses. If I ask you to do cosine inverse of square root of 3 over 2, well, up here, this tick mark here is square root of 3 over 2. It's on your graph, right? Again, lots of spots it could be, but you only look from 0 to pi. So from 0 over to pi, there's only one spot where it's square root of 3 over 2. And again, that answer would be pi over 6. So if I said cosine inverse of that, you'd say pi over 6. Same thing with tan. If I said tan inverse of square root of 3, well, you go to your tan graph, you'd say, does tan equal square root of 3 somewhere? Yes, it does. And then I would only be looking for the one between negative pi over 2, this first asymptote, and positive pi over 2, this asymptote. And that would be this point, would you agree? Which would correspond to pi over 3. So you'd say the tan inverse of that's pi over 3. And again, if the numbers are not on the y-axis, then it's not going to be nice and clean. It's not going to be a nice, pretty radian angle. So you just let your calculator handle it, right? That's pretty much it. Let's continue to look at the review assignment real quick, though. Let's do one thing or so with inverses. Numbers 31 through 35 all have a bunch of inverses. They look kind of scary, some of them, but they're not. Don't worry. What's the scariest looking one? 35 does look scary, but it's not. All these, if you have some patience, are really actually very, 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 very straightforward. So for example, on 35, what's scary about it is it's got a lot of things. First, it says tan inverse of something. And inside of the something is 1 plus sine of pi. So just, like PEMDAS, what do you do first? Parentheses, right? Don't worry about the tan inverse right now. Let's worry about the stuff inside these parentheses. It's got a 1. I know what 1 is, right? It's got sine of pi. But you got a sine graph, don't you? Go look up what the sine of pi is. It is 0. So in a weird way, I'm just saying this is 0, aren't I? And 0 plus 1 is 1. So this problem is really just asking you what the tan inverse of 1 is. And then you go to your tan graph, correct? Where are you going to look for tan? What's it say on the range? From negative pi over 2, right? To pi over 2. What angle between negative pi over 2 and pi over 2 has a tick mark of 1? And there's your answer, pi over 4. Yep. And that's it. No matter how weird of a complicated thing I give you. 32, I won't do it. I want you to do it, but I'll make up one similar to it. Let's say I said cosine inverse of sine of, I'll just do cosine sine inverse of this. So let's say I gave you this ugly weird thing. It's like 32, but it's not. Well, again, parentheses, don't worry about the cosine, right? How about this stuff inside of here? Can we do this? I don't know. Go to your sine graph. Is square root of 3 over 2 on there? Yes, it is. What angle does sine equal square root of 3 over 2? And where are you looking between negative pi over 2 and pi over 2, right? What angle do you see where sine is equal to square root of 3 over 2? Pi over 3, everybody seeing pi over 3? I agree. So this junk is just pi over 3. So this problem in a roundabout way is asking you what the cosine of pi over 3 is. So you go to your cosine graph. And if you go to angle pi over 3, what's it say the cosine of pi over 3 is? No, you're putting an angle into it. Go to pi over 3 and figure out the y value is there. It is a half. That is the correct answer. So after you do all that work, you just get out a half. But these problems aren't doing anything you haven't done before. It's just doing two things at once. Do the inside thing first, right? Figure out the inverse is, or whatever the trig function is. And then once you figure out the inside is, then worry about what the outside function is at that number. Questions over that? And then which ones of these? I see one of these you'd have to do in your calculator. Which one would you have to do in your calculator? 34, right. 0.8 is not on your sine graph, so you would just type in your calculator and read the directions. It says round to the nearest hundredth, so make sure you do that as well. That concludes your review. Do you guys have any questions about anything at all? Okay, then steadily keep working on this tonight. Try to get as much of it done as you can. Don't avoid ones you don't know how to do. Try them And that's what tomorrow's for. How do you do this one? I got stuck on this one. I don't get this one. And that's what we'll finish up tomorrow. Then over the weekend, you'll study it, right? Please, it's a final exam. Actually take some time to study it. Look it over. See what you did. You don't have to do it again, but stare at the problem and say, I know how I got that answer. I know how I got that answer. I can redo that, et cetera, et cetera, et cetera. And if you can know all that, then you should be just fine for the final. That concludes this year's lessons. Tomorrow we'll still have a little lesson, but it's really up to you what we do. And that's all. Have a great day, everybody.